So is my screen visible now?
Sir, not yet.
Tell me now.
Yes.
Yes. So first thing is, what is VRF? So VRF stands for virtual routing and forwarding. Guys, a technique used to create multiple routing table on a single router. What is VLAN? VLAN is used to create multiple broadcast domain on a single switch. In the same way, to create multiple routing table on router, we have what? VRF. By default, whatever subnet you are going to run on this link, and this link, router is going to store all the information in their global routing table, right? Router is going to install all the prefixes in their global routing table. But with the help of VRF, what you can do, you can create three routing table, right? You can create three routing table. If you have two ISP, you can create two separate routing table. You can divide the main global routing table into two parts. I can put this customer, IBM customer, in this routing table and HP customer in this routing table, right? So we can have two different routing table with the help of VRF, right? So if someone asks you like what is VRF, and before talking about the VRF, you should be familiar with PE and CE router, like PE router, CE router, P router, and C router. C router means customer routers. Whatever routers IBM is going to use in their internal network will be considered as C router. And the edge router of customer is known as by C router. Whatever routers provider, service provider is going to use in their internal network is P router, provider router, like router number 2, P router. And the provider edge router are called P router. Provider is. So there are two provider edge router, customer edge, C routers. These are C router, right? So as this service provider is connecting two different customer on router number 1, there should be two routing table, right? Two separate routing table for both the customer, and we can achieve it with the help of VRF. It allows you to create multiple routing table on a single router. When we will configure the VRF, you will get to know why we need to divide it and how everything will work. Now see, this company IBM is also advertising this submit 10.1.1.0/24, and the HP is also advertising same subnet, right? How router number 1 is going to differentiate, or when router 1 will advertise it to other PE router, right? Like the service provider routers network is going to receive subnet from side 1 of IBM, and it will advertise to side 2. It will advertise to side 2. So this PE router will receive these prefixes, it will advertise to their other PE router, and their other PE router will advertise it to the customer routers, right? So how router 3 will get to know that this prefix 10.1.1.0/24 is of IBM or HP, right? So guys, there are some terminology of VRF. To differentiate the route, we are going to use some terminology, right? So hope VRF is clear. Like what is VRF? VRF stands for virtual routing and forwarding. It is used to create multiple routing table on a single router. It allows you to separate the routing table, right? And VRF commonly used in MPLS network, right? So in the service provider network, we are going to run MPLS. Soon you are going to understand MPLS as well now. What is MPLS? Done. So where we are going to use VRF, guys? With MPLS. And here we are going to use one more thing, that is MPBGP. Till now you learned the BGP routing protocol. Today you are going to learn MPBGP as well. The difference between BGP and MPBGP is, guys, the normal BGP is going to manage IPv4 prefix whose length is 32 bits, and MPBGP is going to manage a special type of routes, right, whose length will be not 32 bits, greater than 32 bits, right? So if I will talk about the terminology of VRF, first is RD. RD stands for route distinguisher. Route distinguisher. What is route distinguisher? Route distinguisher is used to make the IP addresses inside the VRF unique, right? Like in the service provider network, it is going to make these two subnet as unique between IBM and HP. Both companies are using same subnet, right? And RD is something who is going to make difference in these two types of route in the service provider network, right? So it is used to make IP addresses unique in the VRF. Got it? Like for IBM, I can use RD value 1:1, right? For the HP, I am using RD value 2:2. So what this router will do, whatever subnet it will receive from IBM, it is going to add RD value, right? So let's say it is receiving 10.1.1.0/24. So it is going to add RD value with this subnet, like 1:1. When it will receive prefixes from HP, same prefix 10.1.1.0, it will add RD value of HP. Now you can see both subnet are, guys, different. And this subnet means IPv4 plus RD value. This is combination of two things, IP address, IPv4 address plus RD value, route distinguisher value, right? So this prefix is called VPN v4 prefix. VPN v4 prefix. And MP BGP is used to exchange VPN v4 prefix. Normal BGP is used to advertise IPv4 prefix, and MP BGP is used to advertise VPN v4 prefix. VPN v4 prefix is what? Nothing but the combination of IPv4 subnet plus RD value. So the logic behind VRF is I am going to insert this interface in a VRF, in one VRF, let's say VRF IBM, and I will define RD value for that VRF, RD value 1:1. Now whatever prefixes it will receive on this interface, it will add this RD value with that prefix. That prefix will become what? VPN v4 prefix. And to advertise VPN v4 prefix from router number 1 to router number 3, we need BGP. Which BGP? MP BGP. So we are going to configure BGP here, right? But BGP is not required between router 1 and router 2. BGP is required between router 1 and router 3. PE to PE router. Like this, guys, there will be multiple PE router in the service provider network who will be connecting multiple customer. Yes or no? Right? So all PE router will have peering with PE router. Like this. This is the service provider network, right? And inside the service provider router, like on the all PE router and CE router, they will be using any IGP protocol like OSPF for the internal connectivity, because let's say on router number 1 and router number 3, between router 1 and router 3, I want to form BGP neighborship. So there are multiple paths. If I will use the physical IP address of physical interface, then guys, if physical interface will goes down, then BGP neighborship will goes down. So it will be better to use one loopback IP address here and 3.3.3 over here and form BGP neighborship with the help of this loopback. Then what will happen? Until and unless any path is available between 1.1.1 and 3.3.3, your BGP peering will be up, right? So we'll form MP BGP peering between router 1 and router 3 with the help of loopback. So on both the router, I am going to configure one loopback. On router number 1, 1.1.1, let me write here. 1.1.1.1 on router number 1 and 3.3.3 on router number 3. Now the most important thing is we need reachability between 1.1.1 and 3.3.3 to configure the BGP, right? Even to configure the normal BGP, guys, between 1.1.1 and 3.3, what you need? You need reachability. So for the reachability, I am going to use any IGP protocol. I can use OSPF. Got it?
Yes.
Right. Then the second terminology is RT. One is RD and another one is RT. RT stands for route target. Route target. Route target is used for route sharing between VRFs. Right? It act as a tag number, right? Like remember the tag value in the OSPF redistribution, in the BGP redistribution. Many times we discussed the tag value. So guys, whenever router 1 will advertise any prefix to router number 3, if it will add one tag number of, let's say 10, tag value is 10, and we have already configured router number 3 in such a way so that like I can tell to router number 3, bro, when whatever prefixes you will receive from router number 1 with tag number 10, that is prefix of IBM, so it will advertise to IBM router, right? And whatever prefixes you will receive from R1 with tag number 20, advertise it to HP. So it is used to differentiate the route, right? Like we can add the tag value with route to identify the customer. Got it? So these are two terminology of VRF. If you are clear with these two terms, RD and RT, then you can understand the VRF. Right? So RT value is a tag which is used to tell to router whether I need to import this route to which VRF, like IBM VRF or the HP VRF. Whatever prefixes it will receive or advertise, it will get to know about the VRF, about the company with the help of RT value, right? So when we will configure the VRF, guys, we will defining two things. One is RT and another one is RD. Just 1 minute. We will be defining two things. First of all, I am going to configure service provider network, means router 1, router 2 and router 3. In the service provider network, we need to configure the IP addresses and we need to configure IGP protocol for reachability between 1.1.1 and 3.3.3, and then we need to configure BGP. So we'll do the BGP configuration later. After that, on PE router we need to create VRF, right? Again we'll configure the VRF later. Before that, let me make reachability between 1.1.1 and 3.3.3. You know the configuration of OSPF in service provider network to make reachability between 1.1.1 and 3.3.3 very well. Even you can configure it. So guys, I'm going to use Notepad for the configuration. It will be easy. So first of all, R1 configuration. On R1, interface F0/0, say no set, and the IP address 12.1.1.1 255.255.255.0. Exit. Even here I can set OSPF network type, OSPF network point to point to point. Then anything else which I need to configure here?
IP OSPF area.
Yeah, to enable OSPF, IP OSPF, let's say process ID 1 and area 0. Done. This is the configuration on router number 1, interface configuration. Then I need to enable router OSPF and I need one loopback as well, 1.1.1. Interface loopback 1, IP address. Here I am going to say 1.1.1.1 255.255.255. Here also I am going to say IP OSPF 1 area 0 exit and then router OSPF 1 and router ID. Router ID 1.1.1.1. Let me copy it and let me paste it on router number 1. This is the simple configuration in service provider network just for reachability between 1.1.1 and 3.3.3. It is not sure to use OSPF only. You can use any IGP routing protocol. Even you can use the BGP as well, right? At the end, I need connectivity between 1.1.1 and 3.3.3. Let me copy the command and let me paste it over here. Some command is interface 0/0 done, all done. So IP OSPF interface brief. You can see OSPF is enabled on F0/0 and loopback 1. So IP interface brief. We have IP address on fast Ethernet 0/0 and loopback 1. Now router 2. Router 2 fast Ethernet 0/0 IP address is going to be 12.2. OSPF configuration will be same. Here I need to add one more interface, interface F 0/1, where IP address is going to be 23.1.1.2 255.255.255.0, and the OSPF configuration will be same. Copy and let me paste over here. Then exit. Right. Router OSPF 1. Here I don't need any loopback, so let me remove the loopback configuration. Now router OSPF 1 and router ID I'm going to set here 2.2.2. Copy and let me paste the configuration on router 2. From here, copy and paste. Done. And now we have neighborship as well, guys, between 1.1.1 and 2.2.2. Router OSPF 1, router ID 2.2.2. Done. So IP OSPF neighbor. Done. Even so IP route OSPF, this router is learning 1.1.1. Now finally R3 configuration, and on R3 we don't need this interface again. This interface is not required, and here IP will be 23.1.1.3. IP OSPF is fine. Loopback IP address, here I need one loopback. Interface loopback 1, IP address 3.3.3.3 255.255.255.255, and IP OSPF 1 area 0. Done. Then router OSPF. Let me copy the
Router ID, sir.
Router ID.
Yeah, router ID.
Sir, router ID.
Sorry. Copy and let me paste it over here on R3. Done. Now we have OSPF neighborship, so IP OSPF neighbor, and so IP route OSPF. I think router ID is not configured on router number 2. Now you can see I am learning 1.1.1. On router number 2 OSPF router ID is not configured. Router OSPF 1 router ID 2.2.2.2. So I have to first clear OSPF process, clear IP OSPF process, say yes. Do clear IP OSPF process, say yes, and now you can define the router ID. Done. Now see, so IP OSPF neighbor. Now 2.2. Now let me verify the connectivity. Ping 3.3.3.3 and source 1.1.1.1. See, there should be reachability. Just wait for some time. Why ping is not working, guys? Yes, ping is working. Now I am not going to configure anything on router number 2. So let me close the console of router 2 here. Done. 1.1.1 and 3.3.3 are reachable with each other. Done. Clear to all?
Yes.
Now on router number 1 I'm going to create the VRF. How many VRF? 2 VRF, because I have 2 company, right? So guys, to create the VRF here you can run command IP VRF and after that name of VRF. So let me use same name of the company, right? Like for IBM I am saying IBM, right? You know, two things I need to define here, RT and RD. So say RD. RD I am using 1:1 for IBM, right? And then route target. Route target value is also, let's say 1:1, or you can use 100:100, anything, right? So you can write it over here like I am using RD 1:1 and route target, because you have to use same on router number 3 on the other P router. Route target is 100:100. With the help of route target value, router 3 will identify that this is a prefix of IBM or HP. Got it? For guys, this company I will be using, let's say RD 2:2. Here I will be using 2:2 and 200:200 for this company, for HP. You can use any value. This is just for the route differentiation. Done. So I have defined both the value here to VRF IBM. Now exit. I have created one VRF. How to verify that? Do so IP VRF. So you can see I have one VRF with name IBM, and what is the RD value, guys? This one. Is there any interface in this VRF? No. There is no any interface in this VRF. So if you will check the routing table, so IP route. So IP route. So this is the global routing table, and we have only one routing table now. All the prefixes will be in this routing table. This is the global routing table. All the interfaces of this router are part of this global routing table. Yes or no? You already know this. All the interfaces of this router are part of this global routing table. So we'll define the interface in the VRF later. Before that, let me create one more VRF over here. For which company? For HP. Here you are not able to see the route target value. So you can open the VRF in detail by running commands. So IP VRF, and here you can say detail, right? With the help of detail command, guys, you can see the route target value. RD value is 1:1 and route target value. See, two things is there. One is export VPN route target community, and another one is import VPN route target community. What do you mean by it? This is one community of BGP, right? We are going to use it for BGP only. Export means whatever prefixes router 1 will advertise to other P router, means to router number 3. It will use what? RT value 100:100, and whatever prefixes it will receive from other P router. If RD value is 100:100, it will import that in which VRF? In this VRF, in IBM VRF. Even you can use like this. See, here I can say for import 1:1 and for export 200:200. So what will happen? Whenever it will export any prefix for VRF IBM, it will use this route target value, and for import it will use this route target value. The important thing is whatever export target value you are using, that should be same on router number 3 for import, right? Means whatever prefixes I will export from router number 1 with RT value 100:100, R3 should be importing that with 100:100. Then only R3 will get to know, okay, this is the prefix of IBM, right? This is the prefix of IBM. So for both I am using same route target value. You can use different as well, right? For receive you are using different. For save transmission, means for the export you are using different. For the import you are using different. Whatever import RT value you are using on router number 1, that should be same as an export on router number 3. and whatever export RT value you are using on router number 3, that should be same on import on router number 3, right? Actually the logic behind it is, I am saying router 1 is advertising some prefix X prefix with RT value 100 ratio 100, right? So if I will tell to router number 3, bro, whatever prefixes you will receive, and if route target value is 100 ratio 100, then import that in VRF IVM. This is like that. Import that in VRF 1, right? If I am saying, bro, whatever prefixes you are receiving with 200 ratio 200, that imported in IBM VRF, then here I have to change the configuration of router number 1. I have to set for export RT value should be 200 ratio 200. Done. Got it, guys? And while configuring, it will make you more clear, right? So like this we can check RT value and RD value. Now let me create one more VRF for the HP. So again the command is going to be IP VRF, and there are two methods to configure VRF, right? This is the basic method, guys, and the easiest method to configure VRF. I can say IP VRF, and the name of VRF this time I am using is HP, right? Then again RD is going to be 2 ratio 2, and route target is 200 ratio 200. I'm using for both, correct? Let's say if you want to configure for import only, so here you can define import, right? For export I have to define export, like that. I'm saying for both import as well export use 200 ratio 200. Now on this router I have two VRF. Do so IP VRF, right? That means, guys, now I have two routing table. Now the only thing is I need to add the interface in VRF, right? Once I will add this interface in VRF IBM fast Ethernet 10/1, right? It will separate one routing table for which VRF, for VRF IBM, and whatever prefix you will run on this link, it will store that in that VRF, in that routing table, or whatever prefixes it will receive on this interface, it will import that in that routing table. It will import that in that routing table. So for now, even you can check so IP route, so IP route, and VRF. What happened? So IP route, and then VRF, I can say what? IBM. So see the routing table of IBM VRF, right? We have now separate routing table. This is a routing table of IBM VRF. In the same way, I have one routing table for HP, but there is no any prefix. So it is key sensitive HP. You can see, right? Now guys, let me add the IP address. Before adding the interface in VRF, if you have configured the IP address, then it will erase the IP. Like interface F0/1, I am saying IP address 14.1.1.1.255.255.255.0. I have configured this IP address, say no set. And now I am going to add this interface in VRF. In which VRF? In IBM VRF. How to add the interface? To add interface, you will run command interface F0/1, and then say IP VRF forwarding. IP VRF forwarding. After that, name of your VRF IBM. Hit enter. So what it's saying? Interface fast Ethernet 0/1, IP address 14.1.1.1 removed due to enabling VRF, right? So do so IP interface. Do so IP interface. It have removed the IP address, right? It have removed the IP address. Now do so IP VRF. But now guys, you can see in IBM VRF I have one interface. Done. Now you can configure the IP over here. So say IP address 14.1.1.1.255.255.255.0, right? Now you can check the routing table of this VRF. So IP do so IP route, and then VRF IBM. See the route. We have one route in the routing table of VRF, correct, guys? In the same way, I am going to add interface F1/0 in which VRF? In which VRF? In HP VRF, right?
HP.
So IP VRF forwarding HP. Done. And then IP address. IP address is for 15.1.1.1 255.255.255.0, and I am saying what? No shutdown. So here now we have two routing tables. So IP route, this is the global routing table. Actually we have three routing table. In the global routing table, guys, you can see 14 network and 15 network is not there, right? Because those are the part of now VRF. In the global routing table, we have loopback interface, we have fast Ethernet 0/0, and this is the route which it is learning through OSPF. Done. And so IP route VRF IBM. In the IBM routing table, we have 14 subnet, right? And in the HP VRF, we have 15 subnet. Clear? Any question till here? Please ask if anyone have any question.
Sir, is the route target same for both the sites, IBM and HP?
IBM and HP. No, it's different. We are using different.
Different. And different for import and export. We can configure, but
We are using same.
yeah, okay, sir. And what if there is a mismatch
No, I
in?
told you, see, whatever RT value you are exporting from router number 1, that should be importing on router number 3. And whatever RT value it is exporting, that should be importing on router number 1.
Okay, sir. If there is a mismatch, the
Then it
route
will not
won't be
work. See,
forwarded.
like if I am saying that, bro, do one thing in VRF, RT value, RT value 100 ratio 100 for IBM. Done. That
Okay.
is for importing, right? And on router number 3, I am saying 1:1, 100 ratio 100 is for VRF HP,
Export.
HP,
Oh,
and
HP. Okay.
ex,
Import.
export.
Huh?
Let's say export here.
Okay,
Now what
sir.
will
Okay.
happen? Whenever router 3 will advertise any prefix of HP, it will add what? 100 ratio 100. And when router 1 will receive it, it will think, okay, this is, I am importing 100 ratio 100 for IBM, so it will import that in IBM VRF, right?
Oh,
Means this customer will get that prefix,
yes. Okay.
right?
Miscommunication.
So it is going to work like this. Got it?
Yes, sir. Got it. Thank you.
Now, now guys, same VRF we are going to create on router number 3, right? So on router number 3 again, IP, VRF, IBM, IP, VRF, IBM, and RD. RD is going to be 100 ratio, sorry, 1 ratio 1, and the route target value 100 ratio 100. If I am not defining import and export, that means for both. Done. Now IP, VRF, HP. RD value is 2 ratio 2, and route target value 200 ratio 200. I am using same for both sides. It is easy to understand, right? That's why. Now do so. IP, VRF. We have the VRF, right? But we don't have any interfaces. So let me add interface F0/1 in IBM VRF. For that, IP, VRF forwarding and IBM. Then NUSAT and IP address. Guys, between router 3 and router 6, I am going to use 36 subnet. 36.1.1.3 255.255.255.0. Exit. Interface F1/0. IP VRF forwarding HP. Right? NUSAT and the IP address. IP between router 3 and router 7 is 30 subnet, 37.1.1, 37 subnet, 37.1.1.3, 255.255.255.0, and no set. Now here, so IP VRF, you can see the interfaces in both the VRF. These are the troubleshooting command. And so IP route, this is the global routing table, guys. This is the global routing table. And so IP route VRF IBM. This is the routing table of IBM, and so IP route HP. This is the routing table of HP VRF. All clear? On both PE router 1 and router 3, I have created the VRF. In the same way, let's say in the service provider network there are 100 PE router. So on all the PE router, according to customer, I will create first VRF. clear? Now the next configuration. Now let me do one thing. Let me configure the customer router like R4, R5, R6 and R7. Guys, tell me which routing protocol you want to use between router 1 and router 4. Let me do one thing. Let me use RIP routing protocol here. RIP. RIP. Done. Here I am going to use RIP. Here I am going to use, let's say, EIGRP. You can use any routing protocol, right? Then same thing over here as well. Let's say EIGRP here and RIP over here. So IBM is using RIP and HP is using EIGRP. So now let me access the customer routers and let me finish the configuration of all customer routers one by one. Let me use the notepad. It will be easy to configure. So guys, on R4 interface F0/0 no set and IP address will be 14.1.1.4 255.255.255.0. Done. Then exit. After the router RIP and network. Which network? 14.1.1.0 and network 10.1.0.0. It will advertise both. And then I am saying no auto summary. It will better to use than both subnet. Network 10.1.2.0. Done. So let me add this command over here.
But sir, you didn't configure the loopback for, you know.
Okay, yes, good. Interface loopback 1 IP address 10.1.1.1 255.255.255.0. Exit interface loopback 2 IP address 10.1.2.1 255.255.255.0. Done, guys. Let me run these all command on router number 4. Fine. Done. Now for the RIP relationship between router 4 and router 1, now I have to enable RIP routing protocol on router number 1. So let me finish the configuration of this PE and this CE router, like router 1 and router 4. Between router 1 and router 4, let me exchange the route. So guys, on router number 1, I am going to say router RIP. But this time the difference over here is in RIP configuration. Till now you had configured RIP on many router for the physical interfaces, but this time you are going to configure RIP for VRF. So guys, you know the address family. Address family is nothing but the network family. You have what? IPv4 network, IPv6 network, right? IPX network. So with the help of address family, we can configure RIP for different types of networks. By default, when I am running command network command over here, that is applicable for IPv4 network, right? So I am going to configure RIP for VRF. So I will use address family, right? By default, RIP is not enabled for VRF. So let me say address family, and address family for which network? For IPv4. And after that, for the VRF. What is the name of VRF? IBM VRF, right? Here you are going to advertise the network, right? If you will run network command over here, that will enable RIP routing protocol on physical interface. Now whatever network command you will run here, that will enable RIP routing protocol for VRF IBM, right? So here I am saying no auto summary, like I can say network and 14.1.1.0. Done. right? Even I can run network 0.0.0.0 command, then also it will only enable RIP on fast Ethernet 1/0, because only fast Ethernet 1/0 is part of IBM VRF, right? So if you have multiple interfaces in IBM VRF and you want to enable RIP on all that interface, you can run network 0.0.0 command. Now, so IP route. Now, I am expecting these two subnet 10.1.1.0 and 10.1.2.0 in the routing table of router 1. So IP route. Even I can say so IP route RIP. Are you able to see any subnet in the global routing table, guys? No.
No.
RIP. There is nothing, right? So I can check so IP route VRF and then
IBM.
IBM. Here
IBM.
you can see we have 10.0.0.0/8 subnet. Yes or no? Why no auto summary command is not working here? So run section RIP. I have added the no auto summary command as well. Okay, RIP version 1.
Version
This
2.
is RIP version 1.
Yes.
Router RIP, and let me define version. Sorry, version 2. Version, what happened here? Version 2. Done. Now on router number 1 also I have to change the version. So say router RIP address family IPv4 and then VRF IBM and I'm going to say version 2, right? Now clear IP route star, and so IP route RIP, then VRF IBM, and then I think I can say RIP like this. Now you can see I'm learning these two subnet. Correct, guys? Got it, everyone?
Yes.
Yes, very good. Now let's configure router number 5, means side 1 of HP. So interface F0/0. Let me cover the previous configuration. Is undo option there, guys?
Control Z.
Yeah, here. On fast Ethernet 0/0, IP will be 15.1.1.5, loopback 1, 20.1.1.0. Sorry, not, I'm using same subnet, correct? Same subnet. Subnet
Yeah.
will be same. And the network, here I am going to run EIGRP routing protocol. So say router EIGRP AS number. Let me use AS number 10. Any AS number you can use. EIGRP ES, let's say 100. Done. So on this router EIGRP ES number 100, then no auto summary and network. Which network? 10.1.1.0 network, 10.1.2.0 and network
Please, 15.
15.1.1.0. Let me copy and let me paste it on R5. Config T, and let me paste the command. Done. So IP EIGRP interfaces. So EIGRP is enabled on all the interface. Now again, let me configure EIGRP for HP VRF here. So how I will configure, guys? Router EIGRP ES number is same 100, correct? But you know,
Yes.
here this ES number is different. This is the ES number for IPv4. I will be using one more ES number inside the address family, and that should be match. So router EIGRP ES number 10, then I'm saying address family IPv4 for which VRF? For HP VRF, right? And now here you have to define the autonomous system number. Auto HP, VRF, clear. Address family IPv4, VRF, HP, and autonomous system number 100. This autonomous system number. Now guys, I am saying no auto summary, no auto summary and network. Which network? I can say 0.0.0
15.
also, it will work. Now see, so IP, here you can see the EAGRP neighborship done, but so IP EAGRP neighbor, it will not show you the neighborship because it is showing the global IPv4 neighbor, right? So I have to check so IP EAGRP neighbor for VRF. For which VRF? So IP EAGRP, I think here VRF, HP, and then we can say neighbor. So here you can see we have neighborship. And so IP route, this is the global routing table. In global routing table we are not able to see any prefixes, right? But so IP route VRF HP EAGRP. See, we have same subnet here, right? And here I am saying IBM, and then I am saying RIP. So we have, you can see guys, router is maintaining two routing table, and in that routing table we have same subnet. Yes or no? This is the reason why I have used same subnet, just to show you. Because this time I have divided the routing table. This is the different routing table. This is the different routing table of router. Now we need to do same thing on this side also, in side 2 also, right? So now let me configure router number 6. On router 6, fast Ethernet 0/0 no cert, and the IP address will be what? 36.1.1.6. Loop back 1, 20 subnet here, 20 subnet here, router RIP, no auto summary. I have to define the version 2, and I am saying network 0.0.0. This is the configuration of router 6. Let me paste it on R6. Done. Now R7, or let me configure.
So how about the address family?
No, on customer edge router we are not going to configure that is family, na. On the
Okay,
customer edge
okay.
router configuration is going to be same guys. On provider edge
Alright.
router we will do that, right? So router
Okay, thank you.
RIP, then address family IPv4 VRF, and which VRF? IBM VRF, right? Now here network, I can say 0.0.0, no auto summary, and version 2. Done. So IP route VRF IBM, and you can see, just wait for some time, soon it will receive 20 subnet. Why it is not receiving? So IP RIP database, tab install this subnet here. Yeah, now it is receiving, correct guys? It was taking some time. Fine. Now we need to configure EAGRP between R3 and R7. So first of all, let me configure R7. On fast Ethernet 0/0, I am going to use subnet 37.1.1.7. Loopback is going to be same, router EAGRP ES number 100. No auto summary, version is not required, network 0.0.0. Copy, and let me paste it on R7. Paste. All done. Let me take you to R3. Config T, router EAGRP ES number 100, address family IPv4 VRF, and this time HP. Autonomous system number 100, and network. Which network? 37.1.1.0, or we can say 0.0.0, and no auto summary. Anything else, guys? No, we have
So,
EIGRP neighborship. Yes,
so I'm so sorry. For autonomous system should be same, right?
yes.
I mean, both. Okay, thank you.
Autonomous system number should be same. This is the requirement of EIGRP parameter. So IP, EIGRP, VRF, and VRF name is HP, and then neighbor. So you can see we have neighborship, and so IP route VRF IBM. We have the subnet here, and Dell. Sorry, HP. We have the same route. Correct, guys? In both routing table. Now both PE routers have the route. R1 have route in the IBM VRF as well as in the HP VRF. R3 also have the route in IBM VRF and HP VRF. Now how to exchange this route between router 1 and router 3? Yes or no, guys? Now here we have one
Yes.
routing table for IBM, one routing table for VRF. In both routing table we have some route. Here also we have two routing table, and both routing table we have. So now we need to exchange this route. Got it? So we need one protocol between R1 and R3 where we can advertise this route. So I'm going to configure here MP BGP now. MP BGP. If someone asks you why we are using MP BGP, we are using MP BGP to advertise VPN v4 route. VPN v4 route means the IPv4 plus ID. IPv4 plus ID. Do you want to see the VPN v4 prefix? Here you can do one thing. Here you can open the prefix in detail by running command so IP VRF, and now I am saying detail, right? Let me maximize it. RD and RT value are visible, and so wait for some time. After that I will show you that. Do one thing. Let me do one thing now. On router number 1 and on router number 3, I am going to now configure the BGP first. So BGP AS number, which AS number you want to configure? Tell me. 100? Is 100 fine? Router BGP AS number 100. Done. Now guys, here also we have to use address family. Address family for VPN v4. VPN v4. Address family IPv4, and then here we have option of VRF. Here I should have one option of VPN v4, but I think which is not available on this router. Let me try once on this router. One command that was the simplest one. Just a minute. By the way, here also we can configure then. We have to configure then BGP for both the customer. Router BGP as number 100, and then address family VPN v4. See, this option is not available on this router. This option is not available. Can I replace router 1 and router 3? Then I have to configure it again. Okay. Now it will be difficult for me to make you understand the basic concept.
Sir, can we take backup of existing router and place it in new router?
Where you will back up?
I
Here don't have TFTP server.
Okay. In real time, is that possible, sir?
Yeah, that is definitely possible. Even here also in EVNG possible. We can connect the router to my local laptop. On local laptop I can install the TFTP server, and then simply here I can run command copy running configuration to TFTP server. Once I will connect this router to TFTP server, it will be reachable. It will be able to ping the local laptop, my physical laptop, and the TFTP server is there on the physical router, so it can ping. Okay, say router BGP